And with this, there's 3 different rules, and the first one that we're gonna learn is what happens if they intersect inside of the circle again, okay? In the last, let me just write this. So here, they're intersecting inside the circle. Okay? Now, in the last section, when they intersected inside of this circle, we were finding like an angle, and do you remember how we used this arc and this arc to find that angle? And we would go 1/2 times this arc AD plus arc EC, and we'd figure it out that way. So that time we were dealing with angles and arcs. This time, we're not dealing with angles and arcs. Instead, what we're looking for is chord lengths or segment lengths. And what this rule says when they intersect inside the circle is you take the part of the chord that is in front of your other intersecting line times the other part of your chord, so it'd be like AB in red times BC in blue would equal the green part of the chord EB times the purple part of the chord BD. So basically what you do is you take the 2 parts of the chord multiplied equal to the 2 parts of the chord multiplied. So we're not dealing with angles and arcs, we're dealing with segment pieces, okay? Now, when I look at this one, again, I'm gonna take the 2 parts of this chord and multiply them. When I go x times 6, I'm gonna write that as 6x. And when I go 3 times 4, that is 12. And then I just solve that by dividing by 6 and x equals 2, okay? Normally they're not that easy, but that one's not bad. This one's not bad either, actually. So you're gonna take the 2 parts of the chord and multiply. So it'd be like 12 times 9 equals x times 8. I'll just write it out like that this time. Now, 12 times 9, is that 108, I believe, equals 8x. And then we're gonna divide by 8, and x would be 13.5 maybe? Did anyone punch that in? Let's see. 1 divided by 8. Whoa. 108 divided by 8. 13.5. So those 2 were just easy algebra, okay? You're gonna see though, when we get to this next page, that we're actually having to use factoring to do some of these, okay? So now, when you do the portions of the chord, here I would do x times x equals, and this one I could see a lot of people getting wrong. I could see a lot of people going 2 times 10. That 10 is only the distance of the radius from the center to the outside. Do you think we could figure out what this distance is? 8. So do you guys get that this whole distance then would be 8 plus 10, which is 18? Does everybody understand that? Okay. So this is going to be x times x equals 2, which is that little part, times the part from that chord all the way to the other side of the circle, which is 18. Now, x times x is x squared 2 times 18 is 36. And then we're going to take the square root and we get 6. Okay? So that is my answer there. Now, if I look at this one, if I go to write it out, I'm going to go x times, now this x plus 7 is the whole rest of this, so it'd be times x plus 7 equals 3 times 6. Okay, now I'm going to distribute here, and x times x is x squared, x times 7 is 7x, and then it's equal to 3 times 6, which is 18. Now you could have skipped a step here and brought the 18 over right away. And hopefully you would notice in this, when you have an x squared, an x, and a number, that's when you have to do trinomial factoring. And we have done this before. Do you guys remember how I showed you on the chart? And then we did this little table. Do you remember what went right here?
X squared.
Very good. Do you remember what went here?
Minus 18.
Minus 18. What went here?
Factors of 7.
It would actually be that negative 18 again. And then this one would be whatever is in front of the x with the sign. So that would be 7. Okay? And what we have to do here is think of two numbers that multiply to give us a negative 18, and they add to give us 7. 2 and 9, and which one would be positive? The 9, okay? So if what you want them to add up to is positive, that means the bigger factor is going to be positive. So it's going to be 9 times a negative 2 is negative 18, and 9 plus a negative 2 is 7. Then if you remember, we could put a 9x here and a negative 2x here. And then we can go back and put how we would get x squared. So x times x is x squared, 9 times x is 9x, x times a negative 2 is negative 2x, and 9 times a negative 2 is negative 18. Okay, so now I'm going to come down here and I'm going to put the factors in. And when there's nothing in between these, do you remember how it was a plus? So it'd be x plus 9, and then x minus 2. Okay, now when we did this, we always, when we went to find what x was, do you guys remember what the shortcut was? It's the opposite. So this is plus 9, so this would be negative 9. Negative 2 would be 2. Now when we did this earlier, both of our answers counted whether they were positive or negative, because we were just dealing with numbers. But for this, we're dealing with segment lengths. Could you have a length that's negative? No. So what that means is this one does not work, and that is our answer. Okay, so you look back at the diagram, only check the negative one. You don't really have to check the positive. And look at, does that negative one give us a negative length? And if it does, you don't use that one. Okay? All right, this one you could do differently, but what do you notice with this one? They're both radii of the circle, right? And what do we know if they're radii of the circle? They're going to be congruent. So isn't x plus 2 going to equal 5? And x would equal 3. And that's all you have to do. You could have done where if that's 5, this is 5, that's 5, and you could have gone 5 times 5 equals x plus 2 times 5 and used algebra to solve that. But if you notice their radii, they're gonna equal each other, and then that's easier. Okay, so if we look at this one here, this is 2. What's this? Okay, so what's this whole distance? 12. Now, let's see if you guys remember this. Back in section 9-3, we learned if you have a diameter perpendicular to a chord, what did we know about those two? They are equal. So this would be x, okay? So if you have a diameter or a radius perpendicular to a chord, that cuts the chord in half, and then if you remember, it also cut the arc in half over there. So now what I want to do is write an equation. So this would be x times x equals 2 times what? 12, the whole thing. X times x is x squared. 2 times 12 is 24. And then we would take the square root. Now, when you guys check the book, do you remember how I talked about you can simplify a radical if there's a perfect square that divides into that? And the perfect squares are like 1 squared is 1, 2 squared is 4, 3 squared is 9. The 1, 4, 9, those are perfect squares. Is there a perfect square that goes into 24? 4 does, okay? 4 times 6, okay? When you have a perfect square under there, you can cross that out and bring the square root of it outside. And the square root of 4 is 2. So the square root of 24 is 2 root 6. But if you didn't write it like that, and instead you just did square root of 24 on your calculator, that's okay. I certainly wouldn't do it this way. If it was like a number bigger than 100, I wouldn't even try that. You can wait till algebra 2 to do that. But if you know what you're doing and you want to, you certainly can do that. Whoops, I didn't mean that. All right, so if I go square root 24, it would be 4.9, okay? So I can say this would be 4.9. Now, in Schoology, you're gonna have a worksheet, and it's gonna say up in the corners which ones to do for day 1. And I believe these will be the numbers that it lists for day 1, okay? So you don't really have to copy that down. I'm gonna go to Schoology and just make sure that is correct. So here's day 1, and then when you go up 1 to 3 and 1 to 3. So just do the ones for day 1. Sound good?
I was in just
All
when I
right.
got home, I literally thought that I was like,